Hello everyone, welcome back to another show, Max Marathon classes. This time JEE Main 2025 complex numbers I'm going to do of January shift. Okay, complex numbers is the first PU topic. Those are in first PU also can watch. Those are in second PU also watch this video, make use of this session. But if you're in first PU, I'll tell you some concepts will link with of complex numbers will link with other topics of maybe straight lines or conic section, or it might be from like determinants. Some mixing type questions are there, so you got to study other things also. If you are in first PU, you might find little bit difficult to understand this right now, but after finishing all the topics like straight lines and conic section, then it becomes easy to listen to this video. Okay, but I'll be explaining everything. And one more thing is that whatever there in the NCERT book is not at all enough to study complex numbers for JEE Mains. Okay, because you have to go beyond NCERT book definitely, because there is many extra concepts like De Moivre's theorem, rotation theorem, correct, e power I theta, that is exponential form of a complex number. Even the polar form itself is deleted from the NCERT book. Polar form itself is not there. Even the argument of a complex number is not there. Only modulus of a complex number is there. That is not at all enough. Okay. So you have to prepare exclusively for JEE Mains. You have to prepare separately. The synopsis part has to be very strong. Geometrical applications also there from this. So I'll show the number of questions that appeared from different topics in this. The concepts like modulus and argument, 3 questions. Geometrical application, 3 questions. Finding a real and imaginary parts, 1 question. Miscellaneous, a mixing type of question is asked. Totally 8 questions are asked from January shift 2025 complex numbers topic. Okay, this is begin with the questions now one by one. Let Z1, Z2 and Z3 be 3 complex numbers on the circle if mod Z is equal to 1 with argument of Z1 equal to pi by 4, argument of Z2 equal to 0, argument of Z3 is pi by 4. ARG denotes the argument. Argument means the value of theta, the angle made by line joining the point P. Suppose P x comma y is a point in 2D. Okay, so you join the point P to the origin OP. How much this OP makes an angle theta with the positive x-axis is called as argument of the complex number. The argument of a complex number can be denoted by this ARG, arg of Z, or arg of Z1 in this case. Here arg of Z2, how to read? Arg of Z1 equal to pi by 4, arg of Z2 equal to 0, arg of Z3 equal to pi by 4. Okay, so given the arguments here, I think there is a mistake in this. It should be arg of Z1 equal to minus pi by 4. Okay, small correction here. This is minus pi by 4. Arg of Z1 is minus pi by 4. Arg of Z2 is 0. Arg of Z3 is pi by 4. Want to find alpha square plus beta square. Given like this, Z1 into mod of Z1 Z2 bar plus Z2 into Z3 bar plus Z3 into Z1 bar the square equal to alpha plus beta root 2. Alpha beta belongs to Z. To find value of alpha square plus beta square. Question asked on 22nd of January, first shift 2025. So this is modulus. That symbol you know, correct? And Z2 bar is indicating the conjugate of the complex number. One small correction in the question, arg of Z1 is minus pi by 4. So 3 complex numbers lying on the circle with mod Z is 1. That means circle has a radius equal to 1. Modulus represents the radius in this case because they lie on the circle, correct? Mod Z is equal to 1 means the circle is having radius is equal to 1 and center is at origin. So given arg of Z1 equal to, according to the question, arg of Z1 is equal to minus pi by 4. Arg of Z1 is minus pi by 4. Arg of Z2 equal to 0. Correct? Arg of Z2 is given to be equal to 0. Arg of Z3 is equal to pi by 4. The given arg of Z1, arg of Z2 and arg of Z3. Arg of Z1 is minus pi by 4. Arg of Z2 is 0. Arg of Z3 is pi by 4. So I can write the complex number. If you know the argument and the modulus, we can write the complex number in terms of exponential form. The Euler's formula also you must know. You must know that e power I theta is cos theta plus I sin theta. That is there. This is you must know. E power I theta is equal to cos theta plus I sin theta. You must know this. And a complex number Z could be written as R into e power I theta. This is called as exponential form. Is called as exponential form of a complex number. and e power I theta is equal to cos theta plus I sin theta. That's called as the exponential form, and that's called as Euler's formula. E power I theta is cos theta plus I sin theta. That's called as exponential form. R is nothing but the modulus. R is the modulus of the complex number. So mod z into e power I theta. I'll be using this. Okay, to work out this problem. Z1, Z2, Z3 we can write using this, because we know the modulus. Because mod z is 1 and Z1, Z2, Z3 are three complex numbers on this circle. Mod z equal to 1 is representing a circle, okay, with center at origin and radius equal to 1 in it. You must know that mod of z minus z naught equal to r represents a circle having center at z naught and radius is r. Okay, mod of z minus z naught equal to r represents circle having center at z naught and radius is r. Okay, center of the circle is z naught and radius is 1. Radius is r here. Here the radius is 1. See, mod of z equal to 1. Mod of z could be written as mod of z minus 0. Correct? That means circle has center at 0, 0 and radius is 1. Mod z equal to 1 represents a unit circle. Because z1, z2, z3 lie on the circle, I can write mod z1 is equal to 1. Mod z1 is 1. Mod z2 is also 1. Mod z3 is also 1. Mod z1, mod z2, mod z3 all are equal to 1. Now we can find out z1, z2 and z3 and substitute there. Okay. So z1 is what? Using this. Z is mod z into e power I theta. So z1 is what? Mod z1 into arc of z1 we know theta. Arc of z1 is the angle here. So e power I pi by 4 using this. So using this exponential form and knowing the modulus and argument, I can write the complex number. Z1 is equal to mod z1 is 1. Correct? Mod is 1, modulus is 1, e power I theta, theta is minus pi by 4, e power minus I pi by 4. Z2 is how much? Z2 is equal to mod of Z2 is 1, 1 into e power I 0, because argument is 0. Argument means angle, angle means theta. Correct? Referring to this, I am writing Z1, Z2 and Z3. Z2 is how much? Mod of Z2 is 1 into e power I into 0. Z3 is how much? Z3 is equal to mod Z3 is 1, mod Z3 is 1 into e power I pi by 4, e power I pi by 4. Now we can write this 1 into this only. E power I theta is cos theta plus I sin theta. So e power minus I pi by 4 is cos of minus pi by 4 plus I into sin of minus pi by 4. This is equal to cos of minus pi by 4 plus I into sin of minus pi by 4. Cos of minus pi by 4 is same as cos pi by 4, which is 1 by root 2. Correct? Sin of minus pi by 4 is minus 1 by root 2. Correct? Minus comes out. Sin of minus theta, minus sin theta. So minus I into 1 by root 2. Minus I into 1 by root 2. Minus I into 1 by root 2. Sin of minus pi by 4 is minus 1 by root 2. 1 into e power I 0 is e power I 0, which is cos 0 plus I sin 0. Cos 0 plus I sin 0. Cos 0 is 1, sin 0 is 0. 1 plus I into 0. This is cos pi by 4 plus I sin pi by 4. Correct? Cos pi by 4 is 1 by root 2 plus I into sin pi by 4 is also 1 by root 2. So I got Z1, Z2, Z3. Okay. Now I will substitute all these things. I need to find, we can erase all these things, not required. Correct. I think otherwise I would have simplified this further and written the values, because I am using that, no? Erase all these things, exponential form. So we need to find this, no? Given, start with this mod of Z1 into Z2 bar plus Z2 into Z3 bar, correct? Plus Z3 into Z1 bar. the whole square. This is equal to, substitute the values of z1, z2 and z3. z1 is here, e power minus I pi by 4. E power minus I pi by 4. Z2 bar is e power minus I0. Z2 is e power I, if complex number z is e power I theta, z bar will be e power minus I theta. That also you must know. If z is e power I theta, no, z bar will be e power minus I theta. Okay, the conjugate. So e power minus I0, that is same as e power I0 only. Z2 is how much? Z2 is e power I0. E power I0. Z3 bar. Z3 is e power I pi by 4. Z3 bar is going to be e power minus I pi by 4. Z3 is e power I pi by 4. Z1 bar will be e power I pi by 4. Correct? E power I pi by 4. Square is there. So multiply means adding the powers because bases are same, no? E power minus I pi by 4. E power I0. I can add the powers. So this will be e power minus I pi by 4 only because plus 0, correct? Adding the powers. I is common, correct? In the power minus pi by 4 plus 0 is minus pi by 4. Add the powers here. What do you get? E power minus I pi by 4 plus e power I pi by 4, e power I pi by 4, e power I pi by 2. Pi by 4 plus pi by 4 is pi by 2. E power minus I pi by 4 is going to be cos of minus pi by 4 plus I sin e power minus I pi by 4 already written here. 1 by root 2 minus I can add the like terms here, correct? So 2 times e power minus I pi by 4 plus e power I pi by 2. E power I pi by 2 is cos pi by 2 plus I sin pi by 2. This will be 2 times e power minus I pi by 4 already written here, correct? 1 by root 2 minus I into 1 by root 2. 1 by root 2 minus I into 1 by root 2 plus e power I pi by 2 is cos pi by 2 plus I into sin pi by 2. Like this we get. So this is equal to 2 into 1 by root 2 is root 2. Root 2 plus 0 is root 2. 2 into 1 by root 2 is root 2. You can take I common here. I if you take common, 1 minus root 2 will get. 1 minus root 2, the whole square. This is equal to, how to find modulus, you know. Mod of x plus I y is root of x square plus y square, correct? Many things you must know here. You must know how to find modulus. You must know the information about the argument. You must know about the exponential form, polar form, everything you must know. What is argument, properties of modulus, everything you must learn here. Okay, how to find modulus we know. Mod of x plus I y is root of x square plus y square. So here root 2 square is 2 plus 1 minus root 2 square, correct? 1 minus root 2 square is 1 plus root 2 square 2 minus 2 root 2. Correct? This entire thing square is there. Correct? 2 plus 1, 3 plus 2, 5. 5 minus 2 root 2, the whole square I am going to get. Correct? So this is equal to square root and square will cancel out because square root means power half. Half into 2 becomes 1. So I'll get 5 minus 2 root 2. Correct? 5 minus 2 root 2. Compare with alpha plus beta root 2. Comparing with alpha plus beta root 2. So if we compare this, correct, no? Square of this plus square of this. Root 2 square is 2. Square of this is 1, correct, no? Minus root 2 into 1 by root 2 is root 2. 2 into 1 by root 2 is root 2. I is common. A is a minus b whole square. A square plus b square minus 2ab. 2 plus 2, 4. 4 plus 1 is 5. So we get, correct. Therefore, comparing we get alpha is equal to 5 and beta is equal to minus 2. Correct? Compare the values. Alpha and beta we get. Then you can find alpha square plus beta square. Therefore, alpha square plus beta square is equal to 5 square plus minus 2 square. 5 square is 25. Minus 2 square is 4. 25 plus 4. Answer is 29. Option D. Question asked on 22nd of January, first shift 2025. Please make a note of this. Just go on, simplify it. Arguments are given, modulus is given, mod of z1, mod of z2, mod of z3 is 1. Write the complex number in the exponential form, r into e power I theta. R is modulus, theta is the argument. Then you have to find this mod of z1 into z2 bar plus z2 into z3 bar plus z3 into z1 bar the whole square. So learn this concepts. E power I theta is cos theta plus I sin theta. That's called Euler's formula. Okay. R into e power I theta is called as exponential form. Exponential form of a complex number. E power I theta is cos theta plus I sin theta. You must know this also. E power I theta is cos theta plus I sin theta. Learn those formulas and how to find modulus, correct? And finally simplify it, okay? And compare. Alpha is 5, beta is -2. So alpha square plus beta square. Alpha is 5 square plus -2 square. 25 plus 4, 29. Move on to the next one. Solution is also shown here, a detailed solution. Move on to the next question. Let the curve z into 1 plus I plus z bar into 1 minus I equal to 4. Z belongs to C. Divide the region mod of z minus 3 less than or equal to 1 into two parts of areas alpha and beta. Want to find mod of alpha minus beta. So first note that mod of z minus z naught less than or equal to r represents the circle, the points on the circle and interior of the circle with center at 3, 0, radius is 1. Okay, so if I give mod of z minus z naught less than or equal to r, mod of z minus z naught less than or equal to r, this is representing the circle with represents the points on the circle and the interior of the circle, represents the points on the circle and the interior to the circle, points on the circle and interior of the circle, interior of the circle with center at z0 and radius is r, with center z0 and radius r. Okay, center is z0 and radius r. Mod of z minus z0 less than or equal to r represents what? The center will be z0 and radius is r for a circle. That is points on the circle and points interior to the circle having center at z0 and radius r. This you must know, the basic concept. So mod of z minus 3 less than or equal to 1 represents the points on the circle and interior of the circle having center at 3. 3 means 3, 0. Z0 is 3, no? 3 means 3 plus I into 0. Center is 3, 0, radius is 1. Okay, so in short, alright, mod of z minus 3 represents less than or equal to 1 represents points on the circle and interior of the circle with center at 3, 0, with center at 3, 0 and radius is 1. Center at 3, 0 and radius r is equal to 1. This sentence you write same thing, okay? I won't write again. And here to simplify this, z into 1 plus I plus z bar into 1 minus I equal to 4. Take the z as a complex number x plus iy. So that z bar is conjugate, becomes x minus iy. The given equation becomes z into 1 plus I, z into 1 plus I plus z bar into 1 minus I is equal to 4. Substitute z equal to x plus iy. X plus iy into 1 plus I. Z bar is x minus iy into 1 minus I is equal to 4. Simplify, go on, simplify this. X into 1, x plus iy into 1, iy, x into I, xi, correct? I into I square is minus 1, minus y, correct? X into 1, x minus iy, x into minus I, minus xi, minus into minus plus I square is minus 1, so minus y, correct? I get plus I square into y, I square is minus 1, so minus y is equal to 4, like this we get. So now iy is going to cancel, these two terms are going to cancel, correct? xi minus xi will cancel, add x and x becomes 2x, same terms with opposite sign will cancel, x plus x 2x minus y minus 2y is equal to 4. correct? Divide the entire equation by 2. So we get x minus y is equal to 2. X minus y is equal to 2. So we get the equation of straight line. This is mod of z minus 3 less than or equal to 1 represents points on the circle, on the boundary of the circle and the interior to the circle, having center at 3, 0, radius is 1. This is the straight line. I can draw the straight line here using the intercept form. The intercept will be x-intercept is 2 and y-intercept is minus 2. If you want, you can write this as x by 2 plus y by minus 2 equal to 1, correct? X by 2 plus y by minus 2 is equal to 1, dividing the entire equation by 2. X-intercept 2 means it passes through 2, 0. Y-intercept is minus 2 means it passes through the point 0, minus 2. So I can draw the straight line. Can represent this. Want to find the curve and divides the region. This curve that is nothing but the straight line. This straight line is dividing the circle in two parts of areas alpha and beta. So we'll represent the circle and the straight line now. So to represent the circle and straight line, we'll draw the coordinate system. Center at 3, 0. 3, 0 lies on the x-axis, correct? X-axis, origin, y-axis. I don't need, I think that side, okay. Still I'll do this. X-intercept is 2 means it passes through 2, 0. Y-intercept is here. So left side of origin is not required here, correct? So we can erase this part to save the space. X-axis, origin, y-axis. Center of the circle is at 3, 0. Correct? 1, 2, 3. 3 units. Center at 3, 0 and radius is 1, correct? So I'll draw the circle with center at 3, 0 and radius is 1 unit. Radius is 1 unit. Center at 3, 0 and radius is 1 unit. Something like this. A rough sketch. If it's not a good figure, you can redraw this. Circle having center at 3, 0 and radius is 1 unit. Center at 3, 0. Radius is 1 unit, okay? And the line is x by 2 plus y by minus 2 equal to 1. So line is passing through the point 2, 0. This is 2, 0, correct? Because radius is 1 unit. So this point will be 2, 0. 2, 0, 1, 0 will be there. This is 2, 0 and 0, minus 2 is here, correct? 0, minus 2. The straight line will pass through these points. 0, minus 2. This is 2, 0. So join the straight line like this. Passing through 2, 0 and 0, minus 2. Now I can find out the points of intersection if you want. You can get the points of intersection. Circle equation is given, correct? X minus 3 the whole square. You can write the equation of circle. Circle equation is like this. X minus 3 the whole square plus y minus 0 the whole square. Y square equal to 1. Y is how much? Y is equal to x minus 2 from this, correct? Y is x minus 2. So get the points of intersection. X minus 3 the whole square. Y will be x minus 2. X minus 2 the whole square is equal to 1. Expand this. What we get? X square plus 9 minus 6x. Here x square plus 4 minus 4x is equal to 1 or minus 1 equal to 0. X square plus x square is 2x square. Minus 4x minus 6x minus 10x. 9 plus 4 13. 13 minus 1 is 12 equal to 0. Divide the entire equation by 2. What we get is x square minus 5x plus 6 equal to 0. So the points of intersection will be at x equal to 2 and 3. Correct? Factorize this. So x equal to 2 and x equal to 3. When x equal to 2, can find out y equal to how much? When x equal to 2, y will be, y is how much? X minus 2. So when x is 2, y is 2 minus 2, that is 0. Correct? And when x is 3, y is equal to, y is x minus 2, 3 minus 2, 1. So points of intersection is, one is at 2, 0, and another point is here, 3, 1. My figure is not so exactly correct. This is 3, 1. Okay, this point. So line joining these two will be vertical line here because the x value is constant, correct? This should come like this. So this point of intersection of the line and the circle, one point is 2, 0, and another point is 3, 1. So this line is going to divide the circle in two regions, two areas. That is, one region is alpha, another region is beta. So I'll find this region first, alpha. Alpha I'll find out. The shaded part is alpha, which is unshaded, no, that is beta. So I have to find alpha and beta, then find mod of alpha minus beta. To find the shaded part, what we can do is, I'll find the area of the quadrant of a circle. Quadrant means 1/4 of a circle. Area of the circle we know, pi r square. Quadrant of a circle means 1/4 of circle. So 1/4 of pi r square. So alpha is going to be, the shaded region is alpha, that we can find out 1/4 of pi r square, okay, 1/4 of the area of the circle minus area of this right angle triangle. This point is 2, 0. This point is 3, 0. Distance between these two is 1 unit. 2, 0, 3, 0 means the distance is 1, correct? Because y coordinate is same, means no need to apply distance formula, just subtract the x coordinate. And this height is going to be how much? This height is going to be equal to, how much? Distance between 3, 1 and 3, 0. That is also 1 unit, correct? Because x coordinate is same. X coordinate is same, subtract the y coordinate. So area of the quadrant of the circle minus area of the triangle, half into base is 1, height is 1. Correct? So very simple. And r is how much? R is 1, radius is 1. So pi into 1 square divided by 4 minus half. So pi by 4 minus half is alpha. So beta is what? The unshaded part inside the circle. What is unshaded? That is the beta, remaining part of the circle, leaving this. So beta, if you want to find out, find area of the circle minus the shaded part, correct? Unshaded area is going to be area of the circle. Area of circle is pi r square. Pi into 1 square. Pi minus this will give the unshaded part. Therefore, beta is equal to pi minus of pi by 4 minus half. Pi minus pi by 4 is going to be equal to 3 pi by 4. 3 pi by 4 minus of minus half plus half. What we want to find is mod of alpha minus beta. Mod of alpha minus beta. Finally, we want this. So alpha I can substitute. Pi by 4 minus half. Beta you substitute. Beta is how much? 3 pi by 4 plus half. Substitute the values of alpha and beta. Pi by 4 minus 3 pi by 4. That is minus 2 pi by 4, which is minus pi by 2. Correct? This becomes equal to mod of minus pi by 2. Minus half is minus 1. Mod of this is going to be plus. So answer is pi by 2 plus 1. Many times questions are asked of this type, okay? Geometrical problems we call this in complex numbers. We must know about the circle also here. Little information is required about the circle, which you're going to study in conic section. If you're not studied, if you're in first PU, don't panic, okay? Nothing to worry. It's not a big deal, all these things. It's a very small problem, okay? Not at all a difficult question. So answer what we got is pi by 2 plus 1. That is 1 plus pi by 2. Option E. Question asked on 22nd of January, second shift. So all the information related to this problem I mentioned here. So what does mod of z minus z naught less than or equal to r represents? I mentioned it clearly. And how to find the equation of circle. If you know the center and radius, I can find the equation of circle. Center is h comma k and radius is r. Equation of circle is x minus x the whole square plus y minus k the whole square equal to r square. Using that I wrote x minus 3 the whole square plus y minus 0 the whole square equal to r square. Y minus 0 is y. And also I get the points of intersection. So at which point the line is meeting the circle, I am finding out. And this is a right angle triangle, okay? This is a vertical line because x coordinate is same. This point was 3, 0, which is the center of the circle, and the points of intersection of the line in the circle are 2, 0 and 3, 1. I put y is equal to x minus 2 in the equation of circle and solve the equation, get the values of x and get the corresponding values of y. Okay, then 2, 0, 3, 1 are the points of intersection. 2, 0, we can substitute, and 3, 1, we can substitute and see it satisfies both the equations. Okay, the distance between 2, 0, 3, 0 is 1. Distance between 3, 0 and 3, 1 also, 3, 0 and 3, 1 also, because x coordinate is same means you subtract the y coordinate. Okay, so we get the answer. So area of the shaded part is area of the quadrant of the circle. Quadrant of a circle means 1/4 of the area of circle. 1/4 of area of circle pi r square minus half into base into height. Base is 1, height is 1. So I got alpha. Alpha is a shaded area. Beta is an unshaded area inside the circle. Unshaded part which is inside the circle. Take area of circle minus shaded part gives the unshaded part, that is beta. Then find mod of alpha minus beta. Okay. So with this we complete the second question. Answer is 1 plus pi by 2. Beautiful figure is drawn here. 2, 0, 3, 0, 3, 1. If you want, you can take a screenshot of this. So beautiful figure is shown here. Okay. So radius is 1 for a circle. Mod of z minus z naught less than or equal to r represents the points on the boundary of the circle and the points on the interior to the circle. So move on to the next one. Mod of z bar minus I by 2z bar plus I equal to 1 by 3. Z is a complex number with the equation of circle with center at C. Area of the triangle whose vertices are at the points 0, 0, C and alpha, 0 is 11 square inch. Alpha square equals to how much? Question asked on 23rd of January, first shift, 2025. So we'll simplify this using the properties of modulus. We know that mod of z1 by z2 equal to mod z1 by mod z2. Using that, I can go and simplify this. Okay, given equation is, first I'll write this in the form of the equation of circle. I need to find the center of the circle. Okay, write this in the form of equation of circle using complex numbers. Equation of circle is what? In the general form or the standard form of the equation of circle is x square plus y square plus 2gx plus 2fy plus c equal to 0. I have to reduce it to that form, and in that case center is going to be minus g comma minus f. Okay, radius is root of g square plus f square minus c. I need to find the center, and using that center I have to find the area of the triangle, and area of triangle is already given to be equal to 11 square units. I have to find alpha, then find alpha square. Okay, simple question. This is also not a big question. So from the given equation, given according to the question, given mod of z bar minus I, correct, divided by 2 z bar plus I is given to be equal to 1 by 3. Okay, use properties of modulus. Mod of z1 by z2 is mod z1 by mod z2. Okay, so this becomes mod of z bar minus I, mod of z bar minus I divided by mod of 2 z bar plus I is equal to 1 by 3. Mod of z1 by z2, mod z1 by mod z2. Now I'll use z equal to x plus iy, so that z bar is the conjugate, which is x minus iy. Conjugate is got by changing the sign of imaginary part. Real part you can keep as it is. Z bar is the conjugate. So this is mod of, correct, z bar is x minus iy. X minus iy minus I divided by mod of 2 into z bar is x minus iy plus I is equal to 1 by 3, correct. So from this you can simplify this as mod of x minus I common, correct, y plus 1 minus I common y plus 1 divided by here mod of 2x, can take I common here, plus I into 1 minus 2y, correct, is equal to 1 by 3. Taking I common, 2x I wrote, plus I into 1 minus 2y. Mod of x plus iy and mod of x minus iy is one and the same. So I'll find the modulus for numerator. Mod is root of real part square plus imaginary part square. So this will be equal to what? Square root of x square plus minus of y plus 1 the whole square. Same as y plus 1 the whole square. Correct? Divided by modulus for denominator is root of 2x the whole square is 4x square, correct, plus 1 minus 2y the whole square. 1 minus 2y the whole square, correct. Modulus is equal to 1 by 3. Do squaring on both sides. Squaring on both sides. Squaring on both sides. What do we get? X square plus y plus 1 the whole square, correct, divided by 4x square plus 1 minus 2y the whole square is equal to 1 by 9. Cross multiply this, 9 into x square plus y plus 1 the whole square, correct, is equal to 4x square plus 1 minus 2y the whole square. On cross multiplication I get like this. Expand this. What we get? 9 into, what we get? X square plus y square plus 1 plus 2y is equal to here 4x square plus 1 plus 4y square minus 4y. Correct? Write all the terms to one side. 9x square minus 4x square becomes 5x square. 9y square minus 4y square, that is 5y square. Correct? X term is absent here. Correct? 9 into 18y, 18y plus 4y, that is 22y. Correct? So this is 18y plus 4y, 22y. 22y, and the constant term 9 into 1 9, 9 minus 1, that is 8, equal to 0. You can divide the entire equation by 5 now. If you divide the entire equation by 5, we get x square plus y square plus 22 by 5y plus 8 by 5 equal to 0. You can compare with the standard form of the equation of circle, x square plus y square plus 2gx plus 2fy plus c equal to 0. Comparing with the standard form of the equation of circle, comparing with x square plus y square plus 2gx plus 2fy plus c equal to 0. Coefficient of x is absent here, correct? Coefficient of x is absent. So 2g is 0, means g is equal to 0. 2f is 22 by 5, so f will be 11 by 5. C is not required. Center is minus g comma minus f. Center C is minus g comma minus f. So minus 0 is same as 0 comma minus 11 by 5. Center we got. Now using that center, I can find the area of the triangle, which is already given to be equal to 11. I want to find alpha. Area of triangle formula, I am using determinants method. Okay, we can use the coordinate geometry formula also. Half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. That formula also you can use. Or else determinant method is there. That is going to study in second PU. Those who are watching the video of first PU students, I am telling you, determinant method is quite easy. You can do other method also. Not a big thing. Coordinate geometry formula also you can use. Or else you can use the formula of determinant. Area of triangle is denoted by delta. Delta is equal to half determinant of x1, y1, 1, x2, y2, 1, x3, y3, 1. This is the formula. Of course, mod is there, okay? Mod you can take for this. Mod of this. Mod of this. Delta is given to be equal to 11. Area of triangle is given to be equal to 11. 11 is equal to half into mod of determinant of x1, y1. First vertex is 0, 0. So 0, 0, 1. Second vertex is C. C we got 0, minus 11 by 5. 0, minus 11 by 5. 1. And the third vertex is alpha 0. Alpha 0, 1. Mod of this. Okay. Cross multiply this. 11 into 2 is 22. When you remove the mod, you get plus or minus. So plus or minus 22 is equal to 0 into anything is 0. 0 minus 0 plus 1. So 1 into 0 minus of minus becomes 11 alpha by 5. 11 alpha by 5. 11 ones are 11 twos are. So alpha is equal to plus or minus 10 I'll get. Therefore alpha square is 100. Alpha square is equal to 100. So answer is 100. Option A. Question asked on 23rd of January, first shift 2025. It's a quite simple question here. Using the properties of modulus, go on simplify. Mod of z1 by z2. Mod z1 by mod z2. Z bar is x minus iy. Go on simplify. Take the modulus. Do squaring on both sides. Cross multiply. I'll get the equation of circle. Find out the area of triangle using determinant method or any other method as you wish. Okay. Alpha we get plus or minus 10. So alpha square equal to 100. That is what we got. Correct. On to the next one. Solution is shown here. And the next one is here. Number of complex numbers z satisfying this. Mod z equal to 1 and mod of z by z bar plus z bar by z equal to 1. Mod z is 1 means the equation of circle it is. Circle with center at origin radius equal to 1. Mod z equal to 1 represents circle with center at origin radius equal to 1. Represents a circle with center at origin and radius equal to 1. Represents a circle with center at origin 0, 0 and radius is equal to 1. Radius equal to 1 unit. Mod z equal to 1. So I can write z as, I can write z in the exponential form. R is 1, modulus is 1. So I'll take z as r into e for I theta. The exponential form I'll use. Take z is equal to r into e power I theta. Okay. Z is equal to, sorry. Take z is equal to r into e power I theta. So z bar will be r into e power minus I theta. Z is R into e power I theta. R is 1, correct? 1 into e power I theta. Z bar is conjugate becomes e power minus I theta. Radius is 1. Directly I wrote the conjugate. Z is e power I theta. So Z bar is e power minus I theta. Note that theta lies between 0 and pi. 0 less than or equal to theta less than or equal to 2 pi, because the points are on the circle. No, circle means the one full circle should be covered, means sweeps of an angle from 0 to 2 pi. Theta lies between 0 to 2 pi for a circle, correct? So I'll substitute the values of z in z bar and solve the equation. How many complex numbers are going to satisfy this? I have to find out. Given according to the question, mod of z by z bar, mod of z by z bar plus z bar by z is equal to 1. Substitute the value of z, e power I theta. Z is e power I theta. Z bar is e power minus I theta. Z bar is e power minus I theta. Z is e power I theta. This is e power I theta. E power I theta becomes e power 2I theta. Correct? Here e power I theta, take it up, becomes e power minus I theta. E power minus I theta, e power minus I theta becomes e power minus 2I theta. E power I theta is cos theta plus I sin theta. E power 2I theta is cos 2 theta plus I into sin 2 theta. Correct? This will be cos 2 theta plus I sin 2 theta. E power I 2 theta, cos 2 theta plus I into sin 2 theta. E power minus 2I theta is cos 2 theta minus, sorry, not this I comes from where? Plus sign here, correct? Plus e power minus 2I theta is cos 2 theta minus I sin 2 theta, correct? Is equal to 1. Here I sin 2 theta cancels, adding the like terms, so you get mod of 2 cos 2 theta is equal to 1, correct? So from this mod of 2 is 2, so I am getting mod of cos 2 theta equal to half. Mod of cos 2 theta equal to half. You have to find the number of solutions for this. Finding number of solutions for this equation is same as finding number of solutions for this equation. Complex number is converted to a trigonometric equation. This was the equation in terms of complex numbers is converted to a trigonometric equation. Already we have done this kind of questions. JEE 2025 April, many questions were asked like this. So solving a trigonometric equation, one question was asked in fact, and many other questions were there of this type, but we didn't use this concept of graphical method. And now I'll be using the graphical method to find the number of solutions for this. Draw the graph of y equal to mod of cos 2 theta and draw the graph of y is equal to 1 by 2 and find the intersection point for that. Mod of cos 2 theta graph we must know in the interval 0 to 2 pi should draw. So I'll draw the graph of mod of cos 2 theta. Okay, I'll mark the coordinate angles here. Also I need to mark the angles like pi by 4, pi by 2, 3 pi for all those things. Correct? 0 is here, pi by 4, pi by 4, pi by 2, 3 pi by 4. Next comes pi. Next is 5 pi by 4, 5 pi by 4, 3 pi by 2, 7 pi by 4 and finally 2 pi. Okay. Mod of cos 2 theta equal to 1 by 2. I want to draw the graph of y equal to mod of cos 2 theta. First of all, you must know the graph of cos theta. Then you must know the graph of mod of cos 2 theta. Okay. Otherwise, you draw the graph of mod of cos theta. Then you can draw the graph of mod of cos 2 theta. So cos theta graph how? Cos theta graph is like this. Y is equal to cos theta. Y equal to cos x graph. Cos x graph will be pi by 2 is here. Pi is here. 3 pi by 2 is here. 2 pi is here. Correct? Cos function. Cos 0 is 1. Cos pi by 2 is 0. Cos pi is minus 1. Cos 3 pi by 2 is 0. Cos 2 pi is 1. This is the graph of y equal to cos x or y equal to cos theta. Okay. This is y equal to cos theta graph. From the graph of cos theta, you can draw the graph of mod of cos theta. Mod of cos theta means whatever present below the x-axis will be shifted above the x-axis. This part will be shifted. So this part is there, from pi by 2 to 3 pi by 2 is below the x-axis, will go up like this. Understood? I'll get for mod of cos 2 theta, mod of cos theta, I'll get the graph like this. graph of mod of cos theta, this will be shifted above the x-axis, like this I'll get. Instead of this, I'll get like this. This will be for mod of cos theta. Okay, from mod of cos theta, I can draw the graph of mod of cos to theta. So everything will be present, the curve entire will be present above the x-axis only because of the modulus function. Correct? So graph will be like this. Cos 0 is 1. Then you put pi by 4. Now 2 into pi by 4, pi by 2, cos pi by 2 0. So like this I get. And at pi by 2, 2 into pi by 2 is pi, cos pi is minus 1, mod of minus 1 is 1. So it goes up like this. Pi by 4, like this goes up. And again comes down like this. Okay, goes up at pi and comes down at 5 pi by 4. It goes up like this. It comes down at 3 pi by 4 and it again goes up like this. Okay, so I can draw, I know maximum value of cos function is 1. Y equal to half if you're drawing, no? Y equal to half is like this. A straight line like this. Y is equal to half. It's a line parallel to x-axis. Y is equal to half. And y equal to mod of cos to theta. How many points they intersect here? See, 1, 2, 3, 4, 5, 6, 7, 8. So this equation has totally 8 solutions. 8 solutions are there for this equation. Therefore, number of solutions is 8. Number of solutions is 8. Another way of doing this problem is, see, mod of cos 2 theta half means cos 2 theta is plus or minus half. Cos 2 theta equal to half will have 4 solutions. Cos 2 theta equal to minus half will have 4 solutions. Totally 8 solutions I can tell. Okay, in the interval 0 to 2 pi, no? Interval is 0 to 2 pi. In the interval 0 to 2 pi, cos 2x equal to half will have 4 solutions. Cos 2x equal to minus half will have 4 solutions. 4 plus 4, 8. So 8 solutions totally I can tell. By graphical method is easy. Draw the graph of mod of cos 2 theta and draw the graph of y equal to half. Y equal to half means y equal to constant. It is a straight line, horizontal line, line parallel to x-axis. Mod of cos 2 theta equal to half. So number of solutions is 8. Option D is the answer. And the solution is also shown here. Okay, solution is shown here. And a nice diagram is also drawn. The graph of cos 2 theta, and this is y is equal to half. Okay, in the interval 0 to 2 pi. That is what we got. Correct? Pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4. Touches the x-axis. Graph is shown here. Move on to the next one. Alpha and beta are the roots of the equation 2z square minus 3z minus 2i equal to 0, where I is root of minus 1. Want to find 16 times real part. Re means real part. I means imaginary part. Real part of alpha power 19 plus beta power 19 plus alpha power 11 plus beta power 11 divided by alpha power 15 plus beta power 15. Same thing is given here. This bracket and that bracket is same. Correct? Only here it is real part of that bracket, imaginary part of the same bracket is multiplied by 16. Question asked on 24th of January 1st, 2025. Same type of question was asked in JEE Advanced. I don't remember the year. Similar kind of question was asked in JEE Advanced. So don't neglect the JEE Advanced PYQs. JEE Mains as well as JEE Advanced. Both you have to study so that you can do very well in the exams. Okay. So please make a note of this question, which is similar to the question asked in JEE Advanced. Some year, I think 2022 or somewhere, not exactly sure. Some year it is asked. Same type of question. So alpha and beta are the roots of this equation. Correct. Since alpha is a root of, see how to begin the problem, that is very important. Sometimes the questions are straightforward. Here we can't make out how to start the problem. So the important thing is the expression looks so big here, correct? This expression is so big, but both are same. That's the one thing, good thing about that, is both are same. And you see the powers of alpha and beta, 19, 11 and 15. Somehow you have to relate. 15 lies between 11 and 19, correct? So that is the important thing to be noted here. So since alpha is a root of, what is the equation given? 2z square minus 3z minus 2i equal to 0. Correct? What do you get? 2 alpha square minus 3 alpha minus 2i equal to 0. I am substituting in place of alpha, in place of z as alpha. Okay? Put z equal to alpha because alpha is the root of the equation, means it is going to satisfy the equation. So from this, what I am going to do is first to divide by 2. What I get? Alpha square minus 3 by 2 alpha minus I equal to 0. Dividing by 2. Now I will divide the entire equation by alpha. So what we get? Alpha minus 3 by 2 minus I by alpha equal to 0. Okay, that means I can write this as alpha minus I by alpha is equal to 3 by 2. Similarly, I can write it for beta because beta is also a root of the same equation. No, similarly, I can write beta as, similarly, beta is equal to beta minus I by 2 equal to 3 by 2, correct? Beta minus I by 2 is equal to 3 by 2. Similarly, beta minus I by beta is equal to 3 by 2 I can write. So consider one of this equation, okay, alpha minus I by alpha equal to 3 by 2. Consider that equation. What I am going to do is, I will do squaring on both sides. I am simplifying it by squaring on both sides. Again, I will do squaring on both sides. I will get in terms of alpha power 4 and 1 by alpha power 4. So that I can simplify this equation in terms of that equation. Because what I will do is, I will tell the idea of this problem. See, alpha power 19 and alpha power 11 is there, no? There what you do is, you take alpha power 15 common. Okay, so that alpha power 4 plus 1 by alpha power 4 remains. So I will show a little bit of simplification of this. See, alpha power 19 is there, correct? I will write here alpha power 19 plus beta power 19 plus alpha power 11 plus beta power 11 divided by what we have, alpha power 15 plus beta power 15. This is the big expression we are having, correct? So what we do is, from the first and third term, we'll take alpha power 15 common. So what remains is alpha power 4 plus 1 by alpha power 4 remains, correct? Between the second and the fourth term, we take beta power 15 common. So what remains is beta power 4 plus 1 by beta power 4. Like this I get, correct? Taking alpha power 4 plus 1 by alpha power 4, beta power 4 plus 1 by beta power 4. And both are going to satisfy. I am going to take common terms because alpha power 4 plus 1 by alpha power 4 will be same as beta power 4 plus 1 by beta power 4. So that will take common. So what remains is alpha power 15 plus beta power 15, that will cancel out. That is the idea of this problem. Then we can find the real part and the imaginary part, okay? This bracket will be same as this bracket. So I can take this bracket common. So alpha power 15 plus beta power 15 is going to cancel. So consider this equation and do squaring on both sides. Consider alpha minus I by alpha. Consider alpha minus I by alpha is equal to 3 by 2. If you do squaring on both sides, what I get? Alpha minus I by alpha, the whole square, is equal to 9 by 4. Correct? 9 by 4. This will be how much? Alpha square plus I square by alpha square. I square is minus 1. So minus 1 by alpha square. And 2ab part. Minus 2 into alpha into minus I by alpha. That will be minus 2i. Correct? Alpha is going to cancel. Minus 2i is equal to 9 by 4. So what we get? Alpha square minus 1 by alpha square is equal to 9 by 4 plus 2i. Again do squaring on both sides for this. Again do squaring on both sides. What do you get? Alpha square minus 1 by alpha square, the whole square. Whole square, okay, is equal to 9 by 4 plus 2i the whole square. 9 by 4 plus 2i the whole square. Expanding this, what do you get? Alpha power 4 plus 1 by alpha power 4 minus 2. Correct? Expand this. What do we get? Expanding this. This will be 9 by 4 square is 81 by 16 plus 4i square. 4i square is going to be minus 4. Correct? Plus 2ab. 2ab part will be 2 into 2 4. 4 is going to cancel. 9 I am going to get. So from this, what I am getting? Alpha power 4 plus 1 by alpha power 4 is equal to, minus to take that as plus 2. Minus 4 plus 2 is minus 2. Correct? So I am getting 81 by 16 minus 2 plus 9i. 81 by 16 minus 2. 16 common denominator. Correct? Here 81 minus 32 becomes 65. Correct? Sorry, 81 minus 32. That will be how much? 49, correct? 49, yeah, becomes 49 there. This is 49 plus 99, correct? See, alpha power 4 plus 1 by alpha power will be same as beta power 4 plus 1 by beta power 4. Similarly, I can write beta power 4 plus 1 by beta power 4 will be same as this 49 by 16 plus 99. Both are same, correct? This is 49 by 16 plus 99. Even this is 49 by 16 plus 99. Correct? So alpha power 15 plus beta power 15 into this bracket is same as this bracket. Both are equal to 49 by 16 plus 99. Correct? 2EB part, 2 into 2, 4, 4 will cancel 99. Divided by what we have is alpha power 15 plus beta power 15. So this will go into cancel here. So what is left is this. This expression got simplified to 49 by 16 plus 99. Want to find real part of this expression. Real part is 49 by 16 and the imaginary part is 9. So required answer is going to be, I'll write here, 16 into 16 was real part of this. Real part of this expression is 49 by 16. 49 divided by 16. And the imaginary part of this expression is 9. Correct? 16 cancels. 49 into 9 is 441. Answer is option D. Question asked on 24th of January, first shift. It's a simple question, but the right approach is important here. How to start the problem is important. That's the most important thing. Okay. Move on to the next one. Answer is 441. Correct? Move on to the next one. Question number 6. O be the origin. The point A is given like this. Z1 equal to root 3 plus 2 root 2i. And the point B, Z2 is such that root 3 into mod of Z2 equal to mod of Z1. And argument of Z2 equal to argument of Z1 plus pi by 6. To find which of them is correct. Options are given and question asked on 28th of January, first shift, 2025. Okay. So Z1 is given. So I have to find out Z2. Okay. So given conditions are mod root 3 into mod of Z2, root 3 into mod of Z2 is equal to mod of Z1. Z1 we know already. Correct. Z2 I have to find out. From this I can write mod Z1 by mod Z2 is root 3. Correct. Mod Z1 divided by mod Z2 is equal to root 3, or mod of Z1 by Z2 is root 3, and arg of Z2 is equal to arg of Z2 minus arg of Z1 is equal to pi by 6. Correct? Arg of Z2 minus arg of Z1 is pi by 6. So what do you get? Arg of Z2 by Z1 is equal to pi by 6. Arg of Z2 by Z1 using properties. So arg of Z2 by Z1 we know, and I know mod of Z2 by Z1. Correct? Mod of Z2 by Z1 is 1 by root 3. Correct? From this I can find out. I need to find Z2. Z2 I need to find. Z1 we know. Or if you take reciprocal and write, this is mod of Z2 by Z1. Mod of Z2 by Z1 is 1 by root 3. We know Z is mod Z into e power I theta, correct? We know this. We have Z, any complex number Z could be written as mod Z into e power I theta, correct? Same way, I can write Z2 by Z1. Similarly, Z2 by Z1 is equal to mod of Z2 by Z1 into e power I theta. Theta is pi by 6 because arg of Z2 by Z1 is pi by 6, no? So argument for that is pi by 6, correct? Otherwise I'll write the one more step there. E power I arg of Z2 by Z1 I should write, correct? E power I theta, theta is for arg. Z2 by Z1 is mod of Z2 by Z1 into e power I arg of Z2 by Z1. Arg of Z2 divided by Z1, correct? So Z2 we can calculate because Z1 we know already. I know mod of Z2 by Z1 as 1 by root 3. Substituting this, looking at this equation, I can write Z2 divided by Z1 is equal to, what is mod of Z2 by Z1? 1 by root 3. 1 by root 3. E power I into arg of Z2 by Z1 is pi by 6. Correct? This implies Z2 is equal to Z1 into 1 by root 3 into e power I pi by 6 is cos pi by 6 plus I sin pi by 6, because e power I theta is cos theta plus I sin theta. So e power I pi by 6 is cos pi by 6 plus I sin pi by 6. Cos pi by 6 plus I sin pi by 6. Correct? Z1 how much? Z1 is root 3 plus 2 root 2i. Z1 is given to us root 3 plus 2 root 2i. Correct? Divided by root 3 z, and cos pi by 6 is root 3 by 2 plus I into sin pi by 6 is 1 by 2. This could be written as Z2 is equal to, what we have, 2 root 3 is common denominator for this. Correct? Numerator is root 3 plus root 2, 2 root 2i into root 3 plus I. This is Z2 we got. Various options are given like this. Area of triangle ABO, it is not ABD, ABO. Area of triangle ABO is 11 by root 3. ABO is a scalene triangle. Area of triangle ABO is 11 by 4. ABO is an obtuse angle isosceles triangle. Various options are given about the triangle ABO or AOB. So A is the point given, no, root 3 plus 2 root 2i. B we got like this, okay, and O is the origin. So we need to find out about the triangle AOB, whether it is a scalene triangle or obtuse angle triangle. We'll verify option B is correct or option D is correct. First we'll verify which kind of triangle it is, and also I need to find the area of the triangle. Okay, so two things I'm going to find out and verify which of them is correct there. Only one answer is correct, of course. So Z2 we got, Z1 we got. What I'll do is, see, a triangle represents roughly we'll draw the triangle AOB. Okay, O is the origin, Z1 is the point here, and Z2 is the point here. Think like this. The triangle is formed like this. Okay, and since they given arc of Z2 by Z1 is pi by 6, arc of Z2 by Z1 is pi by 6 means the angle formed by line joining O and B, this is B, right, and this is A, correct? A is Z1 and B is Z2. So arc of Z2 by Z1 is pi by 6 means angle between the line joining OB and OA, angle formed by the line joining OB and OA, that is going to be equal to pi by 6. This angle is pi by 6. Okay, one angle we know. And we'll find out the length of Z2 minus Z1. See, the OA length is mod Z1. Okay, OB length is mod Z2. If you want to find the length of AB, it is going to be mod of Z2 minus Z1. Okay, mod Z1 we can find easily. Mod Z1, of course, I can find out using this complex number. Root 3 square, root of root 3 square plus 2 root 2 square. Mod Z1 I can find out. Correct? Mod Z1 I'll write here if you want. Mod of Z1 is going to be equal to root of root 3 square, that is 3, plus 2 root 2 square, that is 8. So mod Z1 is root 11 I'm getting. Mod Z1 is root 11. Mod Z1 is root 11. So I can find mod Z2 and also I can find mod of Z2 minus Z1. That will give the sides of the triangle. Sides of the triangle here are mod Z1, mod Z2 and mod of Z2 minus Z1. Okay. So Z2 we know, Z1 we know. I'll find out what is Z2 minus Z1. Z2 minus Z1 I find out. So here denominator is 2 root 3, no? 2 root 3 will be common. Z2 minus Z1. So I'll take common denominator 2 root 3 and write. Here root 3 into root 3 is 3. Correct? 2 root 2 into root 3. 2 root 6i. Correct? Multiply and write. Multiply this. Root 3i. Correct? Plus 2 root 2i into I. I into I is I square. I square is minus 1. So it becomes minus 2 root 2. And I'm taking minus Z1. So minus 2 root 3 into this. Correct? If you want to write one more step. Divided by 2 root 3 is there. Minus Z1. Z1 is how much? Root 3 plus 2 root 2i. This is equal to, I'll take common denominator 2 root 3. Here I can simplify the like terms. Correct? 3 minus 2 root 2 in one bracket. 3 minus 2 root 2 plus I into 2 root 6 plus root 3 minus of 2 root 3 into root 3. Root 3 into root 3 is 3. 3 2s are 6. Correct? 2 into 2, 4. 4 root 6 I. I'll get 4 root 6 I here. 4 root 6 I. Taking common denominator. And denominator is 2 root 3. I can add the real parts here. 3 minus 6 is minus 3. So minus 3 minus 2 root 2. Correct? Plus I into 2 root 6 minus 4 root 6 will be minus 2 root 6. Root 3 minus 2 root 6 divided by 2 root 3 I'm going to get like this. If you find the mod of this, no, mod of Z2 minus Z1 and also find mod of Z2, they will be same. So denominator is same, no? Denominator is same, correct? And mod of Z2 will be same as mod of Z2 minus Z1. Here also multiply. If you multiply this, what I'm going to get? Root 3 into root 3 is 3. And I'm getting 2 root 6I plus 2 root 6I, correct? Plus root 3I, and we have 2 root 2I square, which is minus 2 root 2. Minus 2 root 2 divided by 2 root 3. Correct? So here I can take real part in one bracket. 3 minus 2 root 2 plus I into 2 root 6 plus root 3. Correct? Z2 I'm getting like this. I'll write Z2 here. Z2 is equal to 3 minus 2 root 2 plus I into 2 root 6 plus root 3. 2 root 6 plus root 3 divided by 2 root 3. Like this I'm getting. So if you find the mod of Z2 minus Z1 and mod of Z2, they will be same. Okay. If you want to find the mod for this, denominator is anyway, it's a positive real number. Find the modulus for the numerator, it's a complex number. Mod of this will be square root of square of this plus square of this, correct? Square of this you find out and square of this you find out, add it. So I'll write directly mod of Z2 minus Z1 is going to be equal to 1 by 2 root 3 into root of, here 3 minus 2 root 2 square is same as 3 plus 2 root 2 square. 3 square is 9. 2 root 2 square is 8 and minus 2ab plus 2ab. 3 2s are 6, 6 2s are 12. 12 root 2 I'm getting. 12 root 2. Correct? Here expanding this, root 3 square 3, 2 root 6 square is 24. Correct? 24 minus 4 into root 18. Root 18 is 3 root 2 becomes minus 12 root 2. Minus 12 root 2. 12 root 2 is going to cancel. So 24 plus 3, 27. 27 plus 8. 27 plus 8 is 35 plus 9, 44 it is, correct? I'm getting 17 plus 27, 44. So I'm getting this as root 44 divided by 2 root 3. Or root of 4 into 11, 2 root 11, 2 cancels. Root of 11 by 3 I get. Root of 11 by 3. Same thing I'll get here also, okay? Same thing I'll get here. Root of 11 by 3 I got. 2 root 11, 2 cancels. Same thing I'll get here also. So that means mod of Z2 minus Z1 is same as mod of Z2. Correct? This length, mod of Z2 is same as mod of Z2 minus Z1. Two sides are equal. And we know angles opposite to equal sides are equal. Correct? So angle opposite to this is pi by 6. Angle opposite to this side is pi by 6. Because it is an isosceles triangle, two of the sides are already equal, correct? Then it is isosceles, and the angle opposite to this side also pi by 6. Because angle opposite to equal sides are equal, we know this. So this is equal to pi by 6. This angle and this angle both are pi by 6. So pi by 6 plus pi by 6 is pi by 3. So other angle will be 2 pi by 3. Therefore it forms an obtuse angle triangle. So it's an obtuse angle with isosceles. Answer is option D. And area of triangle, if you want, I can find out. Half into base into height, you can find out. Okay, because it is an obtuse angle triangle, I can use the area of the triangle formula. I can draw one perpendicular. Anyway, I got the answer now myself. Still, you can find out the area of the triangle. Area of the triangle is, it is not a right angle triangle, correct? If you find the area of triangle by using sine rule, we can apply, correct? Sine rule, because I know two of the sides and the included angle, half AB into sine of C. So if you find area of triangle using sine rule, half into one side I'll take this OA and OB. OA how much? Length of OA. Length of OA is mod Z1. Mod Z1 is root 11. And length of OB, that is mod Z2. Mod Z2 will be same as this only. Root of 11 by 3. Root 11 divided by root 3. Okay. Half into AB into sine theta. Sine pi by 6. Sine pi by 6 is half. So I am getting his answer as root 11 into root 11 is 11 divided by 4 root 3. 11 by 4 root 3 is the area actually, but it is not so. 11 by root 3 is given, 11 by 4 is given. Both are incorrect. Answer is option D. Okay. This is area of the triangle formula using area of triangle using trigonometry, not sine rule. Using the trigonometry I can tell. Half AB sine theta. Correct. Half AB into sine theta, where theta is the included angle from properties of triangle. Okay. Properties of triangle, if you know, you can learn this formula. Half AB sine theta. Half into A and B are the two sides. Theta is the angle between those two sides. Half AB sine theta used. If you want to prove this also, mod of Z2 I can show if you want. Same answer I am going to get here. Mod Z2, if you want, I'll show you. This is equal to mod Z2 is 1 by 2 root 3, keep outside because it is already positive. Mod for this will be root of, correct, 3 square 9, 2 root 2 square is 8, minus 2AB, 2 into 2, 4 into 3, 12 root 2, correct, 12 root I am getting here, minus 12 root 2, plus 2 root 6 square is 24, correct, and root 3 square is 3, correct, and here 2AB part will be 2 into 2, 4, 4 root 18, 4 root 18 is 4 into 3 root 2, 12 root 2, correct, plus 12 root 12 right here, plus 12 root 2. So the 12 root 2 is going to cancel. So what I am getting is 1 by 2 root 3, 9 plus 8, 17, 17 plus 27 is 44, root 44 is 2 root 11, correct, root of 4 into 11, 2 cancels, I'll get root of 11 by 3. So I proved that mod of Z2 minus Z1 is same as mod of Z2. Two sides are equal and the angles opposite to the equal sides are equal. Hence, the triangle is isosceles and two of the angles are pi by 6. Pi by 6 plus pi by 6 is pi by 3. So, other angle is got by, so using sum of the interior angles of a triangle is 180. So, the other angle becomes 2 pi by 3 here. So, one of the angle is more than 90. So, it is an obtuse angled isosceles triangle. Correct? Option D is answer. Hope it's clear. Using the properties of modulus, and you must know the property of argument here. Arc Z2 minus arc Z1 is arc of Z2 by Z1 using property, and arc of Z2 by Z1 is the angle between the line joining OB and OA. That is this angle pi by 6. One of the angle is already given to us. The three angles for a triangle. No, one angle already we know. Another angle I got because of isosceles. So hence we can find the third angle. Correct? Is that clear? Please make a note of this. Quite interesting question asked. Move on to the next one. Solution is also shown here. Given mod of Z1 minus 8 minus 2 are less than or equal to 1 and mod of Z2 minus 2 plus 6i is less than or equal to Z1, Z2 are complex numbers. Want to find the minimum value of mod of Z1 minus Z2. So already we know that mod of Z minus Z0 less than or equal to R represents the points on the boundary and interior of the circle with center Z0 and radius R. Correct? We know that mod of Z minus Z0, mod of Z minus Z0 less than or equal to R represents what? The points on the boundary and the interior of a circle with center at Z0 and radius R. Okay? So mod of Z1 minus given mod of Z1 minus 8 minus 2i is less than or equal to 1. So from this we can write mod of Z1 minus of 8 plus 2i. Correct? Take minus sign common. take minus sign common. 8 plus 2 I am getting. So this is representing a circle, points on the circle and the interior of the circle with center at 8 comma 2 and radius 1. Correct? I can draw the circle with center 8 comma 2, radius is 1. So we'll represent that. And this is geometrical application problem. So I can draw the figure and get the answer easily. Minimum value of mod of Z1 minus Z2 to find out. Minimum value of mod of Z1 minus Z2. This is having center at 8 comma 2, correct? That lies in the first quadrant and radius is 1. And another one is given, also given mod of Z2 minus 2 plus 6i is less than or equal to 2. That means what? Mod of Z2 minus of 2 minus 6i less than or equal to 2. Correct? Take minus sign common. Minus of 2 minus 6i. This is representing the points on the circle and the interior to the circle. Center at 2 comma minus 6 and radius is 2 for this. Correct? Radius of the circle is 2 and center at 2 comma minus 6, which lies in the fourth quadrant. This is lying in the first quadrant, correct? Center at 8 comma 2. Center at 8 comma 2, radius 1. So center at 8 comma 2, radius 1. I'll mark here. Center at 8 comma 2. Center is at 8 comma 2, radius is 1 in it. Okay, I'll mark the center as A here. A is the center. For this, center is at 2 comma minus 6 and radius is 2. Correct? So I'll mark center at 2 comma minus 6 and radius is 2 somewhere here. Center at 2 comma minus 6. Radius of the circle is 2. You can draw a little bigger circle if you want, because radius is 2. Correct? There the radius was 1. Radius is 1 for this. Radius is 2 for this. Center at 2 comma minus 6. Center at 2 comma minus 6. Radius is 2. This is B I'll call. To find the minimum value of mod of Z1 minus Z2. Mod of Z1 minus Z2. Want to find minimum value of this. Minimum of mod of Z1 minus Z2. Correct? That means Z1 is a point on this circle or anywhere inside the circle also. Z2 it can be a point on this circle or interior to the circle. So minimum value of mod of Z1 minus Z2 means mod of Z1 minus Z2 represents what? Distance. First of all, you must know what is mod of Z1 minus Z2. Mod of Z1 minus Z2 represents distance between the point Z1 and Z2. Nothing but a distance formula. I can do it. If you take Z1 as x1 plus I y1, Z2 as x2 plus I into I2, it represents the distance between the 2 points. Distance formula I get. Okay. So you must know that mod of Z1 minus Z2 represents distance between the points Z1 and Z2, where Z1 Z2 are the complex numbers. Mod of Z1 minus Z2 represents the distance between the points Z1 and Z2. Okay. So if you want to find minimum value of mod of Z1 minus Z2, I'll take the point on this, okay, and the point on this. Minimum value of mod of Z1 minus Z2 is this. This happens to be the minimum value of, correct, distance between the two. Z1 is any point on the circle or it can be interior to circle. Z2 is any point on this circle or it can be interior to circle. When mod of Z1 minus Z2 becomes least, that is one point Z1 you take on the first circle, Z2 here. This is the minimum distance. If you want to find this distance, what you do is find AB first. AB, that is the distance between the centers. Then subtract this R1 and subtract R2. So minimum value of mod of Z1 minus Z2 is AB minus of R1 plus R2 over. Only so much. Orally we can do this question, you can crack in 30 seconds if you are very familiar with the geometrical meaning of the complex numbers. Okay. AB is what? Distance formula. Distance formula, square root of x2 minus x1 the whole square. 8 minus 2 the whole square. 8 minus 2 the whole square plus 2 minus 6 the whole square. 2 plus 6 the whole square. Correct? Minus of R1 plus R2. Radius of the first circle is 1 Radius of second circle is 2. R1 plus R2. 8 minus 2 is 6. 6 square is 36. 2 plus 6, 8. 8 square 64. Here 1 plus 2 is 3. So this is root 64, root of 64 plus 36, root 100, which is 10. 10 minus 3 is equal to 7. Answer is 7. Option B. Very simple question asked on 29th of January, first shift. Circle is here like this. Okay. A nice figure is shown to you. Center at 8, 2 and 2, minus 6. Radius of this 2, the radius of that is 1. Rough sketch. Here I have drawn circles of same size. I could have drawn a bigger circle actually. Okay. Answer is 7, which you got. Same answer. Correct. Move on to the next one. This is the last question, I think, is of January shift. I'll be doing even April shift also of the complex numbers. One by one, I'm covering all the topics of 2025. Okay, I've done limits of 2025. JEE means not only limits I completed everything till 2019. You can, those are new viewers, please watch all the videos of limits. Synopsis also has been done completely of limits chapter. I've done definite integration of both January shift and April shift. Also, inverse trigonometry is completed. Trigonometry is completed of both January shift and April shift of 2025. JEE means even quadratic equations is completed of JEE mean 2025, both January shift and April shift. Now I'm doing complex numbers like that. I'm covering one by one all the topics. Okay. So let integers a and b belong to this closed interval minus 3 to plus 3 such that a plus b is not equal to 0. You to find number of all possible ordered pairs a comma b for which mod of z minus a by z plus b equal to 1 and satisfying this determinant equal to 1, where omega and omega square are the roots of this equation, x square plus x plus 1 equal to 0. Omega and omega square are the roots of x square plus x plus 1 equal to 0 means if you solve that you get omega equal to minus 1 by 2 plus I root 3 by 2 or minus 1 plus I root 3 whole divided by 2. Omega square is the conjugate of that, minus 1 by 2 minus I root 3 by 2 or minus 1 minus I root 3 by 2. Omega and omega square are conjugates. Minus 1 plus I root 3 by 2 minus 1 minus I root 3 by 2, omega and omega square respectively. So we'll find the determinant first. Simplify this. Given so many things here, a and b are integers belonging to the interval minus 3 to plus 3. A plus b not equal to 0. And the given number of all possible ordered pairs a comma b for which this condition and this condition are satisfied, where omega and omega square are imaginary cube roots of unity, or I can tell they are roots of this equation, one and the same. Omega and omega square are the roots of this, x square plus x plus 1 equal to 0. That means you can use the condition that omega cube is equal to 1 and 1 plus omega square equal to 0. Since omega and omega square are the roots of this equation, x square plus x plus 1 equal to 0, roots of this equation are given to be what? Omega and omega square. What I can use is omega cube is equal to 1 and I can use the fact that 1 plus omega square is equal to 0. Two things I can use. Omega cube is 1 and 1 plus omega square equal to 0. And also given mod of z minus a by z plus b equal to 1. Mod z minus a by mod z plus b equal to 1 from the cross multiply. So mod z minus a, also mod z minus a divided by mod z plus b is equal to 1 is given. So if you cross multiply this, what I am getting is mod z minus a is equal to mod z plus b. Mod z minus a equal to mod z plus b. Solve this determinant. Use the properties of determinant and simplify. Properties of determinant is of second PU. That you will study in second PU. If you are a first PU student, for time being just you have to understand the properties of determinant here. Okay. So to simplify this determinant, I'll use the properties of determinant. I'll use row operations first. I'll use R1 changes to R1 plus R2 plus R3. Okay. Apply R1 changes to R1 plus R2 plus R3. The first row is going to change to first row plus second row plus third row. This is the property I am going to apply. So what will get in that case? Determinant of z plus 1 plus omega square. Z plus 1 plus omega square. Z plus 1 plus omega square. Correct? Everywhere I'll get the first row will be adding applying this property. I'll get z plus 1 plus omega square. Use this 1 plus omega square equal to 0. So I'll get z in the first row entirely. Correct? Z. I am getting what in the first row? first row changes to first row plus second row plus third row. In doing that, the first row elements will be z plus 1 plus omega square. 1 plus omega square is 0 using this properties of omega. So the first row, all the elements become z. Okay. Second row, keep as it is. Omega, z plus omega square. Correct. 1. Then we have third row, omega square 1 z plus omega, correct, is equal to 1. Correct. We can use properties of determinant. A column 2 changes to column 2 minus column 1. Column 3 changes to column 3 minus column 1. So more number of 0 is advantage for us. Expansion of determinant becomes easy. So I am using column operations now. Apply column 2 changes to column 2 minus column 1. Apply column 2 changes to column 2 minus column 1. And also apply column 3 changes to column 3 minus column 1. So the expansion of determinant becomes easy because I'll get more zeros. First column is z omega square. And the second column z minus z will be 0 there. Correct? Z plus omega square minus omega. Z plus omega square minus omega. Here it is 1 minus omega square. Column 3 minus column 1, 0. Here 1 minus omega. 1 minus omega. Z plus omega minus omega square. Z plus omega minus omega square is equal to 1. Like this we get. Expand this determinant. 2 of the elements are 0. Expanding along the first row, I can simplify this. Correct? If you simplify this, what do you get? Z into. Expanding it, this into this minus this into this. Rest other elements will be 0. No need to write other elements. So z plus omega square minus omega into z plus omega minus omega square. Correct? Minus of 1 minus omega into 1 minus omega square. This is going to be equal to 1 because others are 0. Expanding along the first row, I am getting like this. So what we get from this? Z into what we have? Multiply. Here I get 3 into 3, 9 terms. Here I get 4 terms. Many of the terms will cancel out and simplify it. Z into Z is Z square. Correct? Omega square into Z minus omega Z. Next, Z omega. Z into omega. Here omega square into omega is omega cube, which is 1. Correct? Minus omega square. Next, minus Z into omega square. Minus omega power 4, that is minus omega because omega cube is 1. Plus omega cube, which is 1. Correct? Minus, I'll write here only. Minus 1 into 1, minus 1. Minus into minus, plus omega. Here minus 1 into minus omega square, plus omega square. Minus into minus into minus minus. Omega cube is 1. Is equal to 1. Correct? So Z square cancels. I mean not Z square. Omega square Z, which is cancelling, I'll mark here using other ink. Whichever is cancelling will mark it properly so that becomes easy to identify. Okay. See, omega square Z is cancelling. Omega square Z cancels. Correct. Plus 1, minus 1 cancels. Here plus 1, minus 1 cancels. Then minus omega Z plus omega Z cancels. Plus omega minus omega cancels. Correct. So what is not cancelled? Even omega square is cancelling here. Minus omega square plus omega square cancels. So whichever is marked white no is cancelled. Cancelled. All these things are cancelled. Correct. So what is left out is only Z square. Correct. Everything got cancelled. So Z square into Z, that becomes Z cube. Z cube equal to 1 I am getting finally. After simplifying so much. What I am getting? Z into Z square is equal to 1. That means Z cube is equal to 1. Z cube is equal to 1 means cube root, Z is cube root of 1. Cube root of 1 means cube root of unity. Cube root of unity is 1 omega square. Correct? Z cube is equal to 1 means Z is equal to 1 omega and omega square. 3 values I am getting. So take Z equal to 1 first case and solve this equation. You solve this equation. Mod of Z minus A equal to mod of Z plus B. I have to find the ordered pairs A comma B. How many ordered pairs are there satisfying these two? The equation satisfied by this is Z cube equal to 1. Z is 1 omega square. That takes Z equal to 1 and solve. How many ordered pairs are there to find out? A comma B. So in this interval. That too in A and B are integers. A and B are integers in the interval minus 3 plus 3. So taking Z equal to 1, case 1. Okay, case 1. Case 1 we have taking Z is equal to 1. Take Z is equal to 1. If you take Z is equal to, this equation becomes what? Mod of 1 minus A is equal to mod of 1 plus B. Correct? Mod of 1 minus A equal to mod of 1 plus B means what? 1 minus A equal to 1 plus B. 1 minus A equal to 1 plus B, or 1 minus A equal to minus of 1 plus B. Correct? Possibilities. From this, here plus 1 cancels both the sides. I'll get A plus B equal to 0. I'll get A plus B is equal to 0. This is not possible. I told A plus B is not equal to 0. So this is rejected. Rejected because A plus B is not equal to 0 is mentioned. So from this, what do you get? This is 1 minus A is equal to minus 1 minus B. So what we get? 1 plus 1, 2. 2 is equal to A minus B. So how many ordered pairs are satisfying this equation? I have to find out. A minus B equal to 1 plus 1, 2. A minus B is equal to which ordered pairs will satisfy? You can start with taking A equal to minus 3. If you take A equal to minus 3, if you take A equal to minus 3, what happens? Take A equal to minus 3. If you take A equal to minus 3, B is how much? Otherwise, you can write B as A minus 2. That is better. B is A minus 2. Correct? B is A minus 2. If you take A equal to minus 3, B becomes minus 5. That is not possible, right? Minus 5 is not there. A is minus 3 if you take. B becomes minus 5. Which is not possible. A is minus 5. I'll get B is equal to minus, A is minus 3 if you take. B is equal to minus 5. Not possible. If you take A is equal to minus 2. B is equal to how much? If you take A is equal to minus 2, B will be minus 4. Minus 4 is not there, correct? In the interval minus 3 to plus 3. Both A and B are lying in that interval and should be integers. If you take A equal to minus 1, B is equal to how much? A is minus 1, B will be minus 1, minus 2, minus 3. This is possible, correct? If you take A is equal to 0, B will be how much? 0 minus 2, minus 2. This is possible. A equal to 1 you take. B is equal to how much? 1 minus 2 minus 1. Possible. Correct? A is equal to 2 you take. If you take A is equal to 2, B is equal to how much? 2 minus 2, 0. And this case is not possible because here A is equal to 1, B equal to minus 1 means A plus B becomes 0. No? A plus B is not equal to 0. This case is not possible. Sorry. A plus B is not equal to 0 as mentioned, right? A plus B is not equal to 0. Here A plus B will become 0, right? So this case is not possible. Be cautious about this. A is 2, B is 0, correct? If you put A is equal to, B becomes 0. This is possible. And finally, we can take A is equal to 3. If you take A is equal to 3, B is going to be 3 minus 2, 1. So I'm getting 4 cases here, correct? A is equal to minus 1, B equal to minus 3, A equal to 0, B equal to minus 2, A is equal to B equal to 0, A equal to 3, B equal to 1. B is covering all values from minus 5 to 1. All the values are covered, no? Minus 5 is not, minus 3 is there, minus 2, minus 1, 0, 1. If you want to take B is equal to 2, A will be 4, which is not possible. If you take B, whether you see whether B values are covered here, that also you can try if you want. If you take B is equal to, B is actually take the values minus 3 to plus 3, no? Minus 3 is there for B, minus 2, minus 1, 0, 1. If you take B is equal to 2, B is equal to 2 if you take, A becomes 4, not possible, correct? If you want to write that also. If you take B is equal to 2, A will be 4, correct? And if you take B is equal to 3, A will be 5. This is not possible, not possible. 4 and 5 for A is not possible. A take values between minus 3 to plus 3 on integers. So only 4 cases are possible here, okay? So that was for case 1, mod Z equal to 1. I mean Z equal to 1. Z equal to 1 I got. Here Z equal to next case omega I'll take. Omega and omega square are equivalent. So I'll get only 2 cases. I'll discuss only 2 cases here. If you want, you can try with Z equal to omega square. That is equivalent to Z equal to omega. So you put Z equal to omega and so on. Case 2 is here. Okay. Case 2 I'll write here. Case 2. Case 2. Take Z is equal to omega. If you take z is equal to omega, what we get? Mod of omega minus a, mod of omega minus a is equal to mod of omega plus b. Omega is imaginary cube root of unity, or omega is the root of this equation. Omega value you must know, minus half plus I root 3 by 2. You must know the value of omega, okay? I'll substitute the value of omega and simplify. This is mod of minus half plus I root 3 by 2 minus a, okay, is equal to omega is minus half plus I root 3 by 2 plus b. Take the modulus for this complex number. Mod is root of real part square plus imaginary part square. Minus of minus a is a real number, real part. So minus of minus a square is same as half plus a square. So root of this will be half plus a square, half plus a the whole square. Root 3 by 2 square is 3 by 4. Here root of, here minus half plus b square, correct? Minus half plus b the whole square plus root 3 by 2 square, 3 by 4. Do squaring on both sides. So root goes, 3 by 4 is going to cancel, correct? So half plus a the whole square equal to b minus half the whole square I'm going to get. I'm going to get here half plus a the whole square, half plus a the whole square is equal to b minus half the whole square, b minus half the whole square. Expand this, 1 by 4 plus a square plus 2 into half into a, that is a. Here b square plus 1 by 4 minus 2 into b into half, that is minus b, plus 1 by 4 is going to cancel, identical terms. I can write this as a square minus b square is equal to minus a minus b, correct? Minus of a plus b, I'll write. And a square minus b square we know, a plus b into a minus b. A plus b into a minus b is equal to minus of a plus b. Because a plus b is not equal to 0, I can cancel a plus b here. So what I am going to get is a minus b equal to minus 1 finally. A minus b equal to minus 1. That means a is equal to b minus 1, or b will be equal to, b is a plus 1 I can write. So b is equal to a plus 1 I'll write. B is equal to a plus 1. I have to verify how many integers are going to satisfy this condition. With both a and b are integers in the interval minus 3 to plus 3. How many ordered pairs are there? I have to find out. B is equal to a plus 1. I have to verify. So we can start with a equal to minus 3. If you take a equal to minus 3, b will be minus 2. That's possible, right? So one by one we can write, list out the integers a and b satisfying this condition. B is equal to a plus 1. I cancelled here a plus b so that a minus b equal to minus 1, because a plus b is not equal to 0. So I can write on the integers here. Here I'll write. If you take a is equal to minus 3. If you take a is equal to minus 3, b is equal to how much? Minus 3 plus 1, minus 2. If you take a is equal to minus 2, b will be minus 1. If you take a equal to minus 1, b will be equal to how much? Minus 1 plus 1, 0. Correct? If you take a is equal to 0, b will be 1. Correct? A is equal to 0. Correct? No? Minus 3 plus 1, minus 2. But that all the three cases are possible. If you take a equal to 0, b will be 1. Correct? A equal to 0 if you take, b will be equal to 1. If you take a equal to 1, b will be 2. Correct? A is equal to 1, I'll write here. Remaining cases, a equal to 1, b is equal to 2. A is equal to 2, b is equal to 3. A equal to 3, b equal to 4. That's not possible, right? Correct? A is equal to A is equal to 3, b is equal to 4. This is not possible. So I covered all the values for a, minus 3, minus 2, minus 1, 0, 1, 2, 3. For b values, which are values covered for b? B is So A is 3, B is 4, correct? B values, whether it's covered everything from minus 3 to plus 3. Minus 3 didn't take, no? Minus 2, minus 1, 0, 1, 2, 3. If you take B is equal to minus 3, what happens? If you take B is equal to minus 3, A becomes minus 4, correct? If you take B is equal to minus 3, suppose. Minus 3 minus 1, A will be minus 4. This is not possible, correct? So I'm getting only 6 cases. Here we got 4 cases. Here I'm getting 6 cases. These cases are possible. 1, 2, 3, 4. This is possible. 5, 6. These two are not possible. So everything I've written, all the cases. Here we got 4 cases, correct? These two are not possible. This is not possible. 1, 2, 3, 4. Here 5, 6, 7, 8, 9, 10. 10 cases are possible. So number of ordered pairs A, comma B satisfying this equation as well as this equation, where omega and omega square are the roots of x square plus 1 equal to 0 is answer 10. Question asked on 29th of January, second shift 2025. Very nice question. Okay, it's a combination of both complex numbers and determinants. Solution is also shown here. If you want to take a screenshot of this, detailed solution is explained here. Correct? Here we got 4 cases and here I'm getting 6 cases. 6 possibilities, 4 possibilities, total 6 plus 4, 10. Z equal to omega into, if you take Z equal to omega square, now I'll get the same ordered pairs. Same condition, I'll get the same ordered pairs. Remember, A plus B is not equal to 0. Okay, with this, I completed all the questions of complex numbers, January shift, okay, 2025 JEE mains. All the questions have been covered completely. Detailed explanation is also given for all the questions. Wherever the geometrical figures were there, figures are also drawn. Okay, with this, we completed all the 8 questions asked from complex number chapters, January shift 2025. Many more videos will be uploaded in the coming days. Please do subscribe to my channel. Very beneficial to you. Okay, with this, I conclude. Thank you.